Hi guys, I wanted to show you an example of a polynomial function that we can tackle without needing the techniques that we've been using the past couple of weeks. So consider f of x equals x to the fourth minus x squared minus 2. If you tried to solve this problem using synthetic division and Descartes' rule of signs and the rational zeros theorem, you wouldn't get anywhere and it'd be really frustrating. So you might find your p's over q's and test all of those with synthetic division and none of them would work. And the reason is this polynomial function doesn't have any rational zeros at all. So you might be thinking to yourself, well, if it doesn't have any rational zeros, then we can't solve the problem. And that's not true. We actually need a technique that you saw in Algebra 2, and we're just going to put it into our context here. So if I want to find the zeros of this polynomial function, which is going to be the same as factoring it, we'll take the function and set it equal to 0. So x to the fourth minus x squared minus 2 equals 0. So, like I said, synthetic division won't work. So we need to notice that there's a pattern in the exponents, and we'll say that this polynomial equation is in the form of a quadratic. So let's go look over here. A quadratic equation you normally think of as ax squared plus bx plus c. But look at the exponent. You have a square, 2, and then you have half of that to get a first power, then you have a constant term. So we have a power, half of that power, and a constant term. And that's exactly what we have with this fourth degree polynomial equation. We have a power, we have half of that power, and then we have a constant term. Because of that, we can factor as follows. We have x squared times x squared, giving us x to the fourth. Don't forget the equals 0. We have a minus 2 and a plus 1. Negative 2 times 1 is negative 2. And then if you test the outside and the inside, you see that we have plus 1x squared minus 2x squared to get us the negative 1x squared we needed in the middle. So now, if you set each factor equal to 0, and solve these two equations. Oh, sorry, I skipped a step on this one. I went ahead and moved the one to the other side, which is what you do. That's what we do here. Move the 2 to the other side, take the square root on both sides, and you get plus or minus the square root of 2. That's 2 of your zeros. Since these are real numbers, these would be x-intercepts on the graph. But here, when you take the square root on both sides, you get x equals plus or minus I. So these are not x-intercepts because these two zeros are complex numbers. So we found all 4 zeros to the polynomial. 2 of them are x-intercepts, 2 of them are not. But notice that none of them are rational numbers. So the stuff we've been doing recently simply won't work for this particular polynomial, but we can still tackle it if you remember factoring in the form of a quadratic. So from here, if you wanted to graph this polynomial, you could use the leading term test. You could write it in completely factored form, x minus root 2, x plus root 2, x minus I, x plus I. So you can do whatever you want with this polynomial. Anyway, I wanted to remind you of this technique. So see you next time.